I can log out, I can kill myself, I can do whatever I want. I don't have to wait. Instead, he is going to his job. Okay? That is the daemon process. Intentionally change the parentship to the kernel. What is the benefit? Operating system can take care of such a process. Like any processor end with the D, FTPD, HTTPD, and something D. You can find a lot of such a SSHD. D represent daemon process. Their parent ID is always 1. So, in other words, some of the operating system called this daemon process as service process, like the Windows or Android. So these are the process, special case of the processor. So daemon process definitely is a normal process. Okay, it's kind of web service. The zombie process, you don't have to worry about too much. Most of the time it will be gone. However, open process, you need to take the consume the waste of your resource. So these are the process. So when I'm saying the terminate, there are different levels of termination. So normal termination means end of your instruction. Then the return code, usually 0, is a normal. But sometimes I want to firstly stop. He's studying at the library. Then inform to you go out, kick out him. So you can firstly terminate. Then at that time you can use the kill command. So kill, sometimes when you search the Google or the manual page regarding to the command, there are different levels of the command information. Some of them are executable, some of them are system library. So for example, the kill is used for both the command as well as the library. So you can send when you terminate, forcefully or normally gracefully, send the signal. Okay? So signal, so give the signal, you leave. But at that time, there are different levels. Most of the time, it's a 0 to 15, different level. Okay? So for example, -9, kill -9, then process ID. You learn actually in your exercise like here, -1, the PID means so really force the forcefully stop everything and return the resource, then remove the PCB from the PCB process table. Okay, so most powerful the signal. So from time to time you use this one as an admin when you find like the open process. Okay. And the others are not much used, but the different levels. Some of them are gracefully, which means so even though send the signal, so you leave, but the level is until he finish his study. Like no matter how it takes, like the 10 hours, 10 days, doesn't matter. So different level of signal is giving the signal to the process. That is the process termination. The units. So I already mentioned about the zombie and the open. Okay, then, so these are the process management. Then we talk about the parent process create one child process, and your program will be executed by one child process. But sometimes we need to work. We need to create the multiple processes. For example, this is an example of the multi-process architecture like the Cont. Do you realize that if you go to the taskbar, task manager, how many Cont processes are running? Several. And it usually consumes a lot of resource. Nowadays, from time to time, I'm using the Microsoft Edge. But when you see the task manager, they are running the multiple process simultaneous. One of them is using browser, showing your browser. The other process is rendering. Rendering means kind of the combine all the different resources. And there is another process, the receiving. Like the first you receive the text, the process is working for the networking, receive the image or the video file, so on. So they are working together. So which means nowadays it is normal to create the multiple child process for one task, one job, showing using the browser, something like that. Then problem is they need to communicate. So if you are working together for the classroom project, like the project, this, even though this is not the group project, in case of group project, most important part is communication. So you guys need to work. I know that nowadays the messenger is the most popular way. Yes, so we are using messenger like the communication method for the multiple processes. So for the multiple process communication, we call it interprocess communication. Why is it called the interprocess? It's not intra, it's not the internet, it's between the or among the processes in the operating system. So there are the communication method. There are two types of the communication method. So one is using the shared memory. Like we have the Bluetooth board here. So shared memory. Then put the message over here. Then somebody can watch. And if I have any question, and put the discussion the group on Canvas. Okay, you can use the shared resource. On the other hand, the message passing is that we are going to create the data structure on the memory. That's called like the queue. Then we put the message to entry. And this is the sender. And there is a receiver process. Receiver process can take out from the such a queue. Okay, message queue. This is a very popular way, message passing. So using the queue structure. So there are two main. And there's another one which is called the semaphore. Using the semaphore, we will discuss about the semaphore later during the synchronization problem. But these two are the most popular, the interprocess communication, IPC. Okay, so you can also check the IPC, which means mostly research on the memory, how much the memory are allocated for the such a interprocess communication, and or any message queue are created. Example of the such a messaging is email. Okay, you have an inbox. Somebody put your message in your inbox. Then when you log on, then you can take out. Okay, but at that time the message is receiver is specified. Sometimes it can be shared depending on the permission, access control. So this slide shows how they are different. It's just using the shared memory. You can allocate the memory area. If I ask you to implement shared memory interprocess communication, how can you do that? Always system library. Okay, so you can create the shared memory for communication using system library. So like here's the example SHM. Where is that? This one? Yes. So it's a POSIX case. It's a Unix, the Linux case. You can create a SHM open. So you can define the message, and the size is the 4K, and you can create the memory area for shared memory like that. What about the message queue? Also, you can create such a messaging queue, like it's called the pipe. Do you remember the pipe that we used before? Yes. PS minus EF grep, something like that. This is called pipe. How many processes are created? Two processes. Then output of this one will be input of this using message passing. This one. Output of PS will be input of next connect. So this is the one of the implementation of the IPC, the message passing. Okay. So this is the shared memory, and then the message queue is the operating system provide such a data structure to shared by the multiple process. Then you are able to communicate. Okay. One of the most popular example of such a message queue is the pipe. So you can also create the pipe for the communication. Okay. So they are working together. These are the basic things so you can understand. Sometimes one thing, not directly related to this one. So when we talk about the algorithm of the computer science, so instead of try to solve the problem for specific problem, instead of the small view of the problem, you do better have the kind of generalized model. How do we understand? For example, in this case, the communication. Communication can be understood by consumer and producer. Consumer and producer problem. Somebody generates, send the data, message, and the other process receive consumer. So we can understand any types of similar problem as the consumer and producer problem, which means that we can create the two process. Okay, one is a producer, another one is consumer. When you develop the email system, sender and receiver, then how do they communicate each other? At the time, I'm going to use a shared memory. So at the time, we can create a buffer for the communication. So this one is not only for the IPC, but it's kind of a model of the problem. So we will see this kind of model details in the synchronization issue. Synchronization means when we share something area, like the shared message, what if the two process share the same data? He'd like to change it 1. He'd like to change it 2. What will be the output? We cannot guarantee. It may be 1, it may be 2, right? Because we are sharing the data. And they compete, which is called the synchronization issue. Synchronization problem. Synchronization problem is a critical problem, really, in any of the computer science algorithm. Because we are sharing the resource, we cannot guarantee the output. So one time, the last year, when I have a chance to meet the Priceline.com, the CTO. So he's the Priceline. Anyone who use the Priceline? Yes. So it's kind of they have opposite way. So I try to go to the India and post them. They can find some of the travel agent. They post I can give the $600 or whatever. Then take it. It's a slightly opposite way, but they change it the strategy. But anyway, the question is I asked actually not me, other professor asked when you have an interview with a new employee or the student, what is the most popular, what do you want to see? Then his answer is he always asks the synchronization problem. Because so there the agent, the client are the 100,000 of the travel agent. Sometimes the airplane company and sometimes the small travel agency. So each and every company use different data and the network and data structure. Some of them are using the JSON file, some of them are using the old-fashioned, like the 40 years ago, such a system. So they need to combine such the heterogeneous source. Then sometimes some of the agents provide the different price for the same ticket. Then they compete each other. So how the synchronize such the race condition that is critical, so he usually asks such a synchron. So synchronization problem is not a system problem. Even application has a synchronization problem. So this is we can understand the communication as a producer and consumer model. So we will see the details later about this one. Message passing is we can create the message queue and can be used for the communication. One of the most popular application is a mailbox. Okay, we can create a mailbox, then the sender put the message, create the message, and receiver read the message. At that time, you can specify. Problem is if you share this message, you don't know. He try to send the message to him, but if you do not specify, so you can little bit more details define such a message. Whether this is the shared or this is for public, this is for specific process ID. Okay. And at the time, there are different types of the synchronization. Different types of the communication. One is asynchronous, another one is asynchronous. Synchronous means in terms of a network. I expect that you already took the network class. So synchronous means you check when you send the packet, the receiver, I did. Then next packet, next packet. On the other hand, asynchronous means you don't care whether receive or not. Keep sending, like the UDP and TCP. And what about the email? Email is synchronous or asynchronous?
Asynchronous.
Can you check whether I received the email or not? Sometimes it lost. Only in case you are using same email server, you can check it, like the Gmail. You can check whether send the Gmail from the Gmail. You are able to check. Otherwise, you don't know. Okay? Because of that, sometimes students email me. Then the call. Did you receive my email? Yes, because it's asynchronous. It's just sending such a data. So you need to consider such a synchronous, asynchronous for the communication. Okay? And this one is the example of the system library for the shared memory. Okay, you can create the shared memory. It's nothing but MALLOC. Okay, memory allocation with permission and size. So it's a read and write permission, and it's we will see that this one actually the hard explained a little bit, but we will see the more detail. And this is the truncate, which means flush out. This is an example of the POSIX Producer, which means create the message. Okay, so which means create the shared memory, and it's a read and write. And consumer is the read. At this time, it's a read only, existing one, the read only. Okay. So another example of the message using the Mahu. Mahu is the microkernel used in the iOS. Okay, they are using such a thing. And also, there is another one. When we talk about the thread, we will discuss a little bit more. So, we have for example, do you remember the dual mode of the operating system? Dual mode means we have kernel and user mode. Okay, so user mode, I need to create a file. Then, do you remember how do they communicate? Message passing. Okay, so if you remember so like create a file. How do you create a file? What kind of file? Okay, you need to give the argument, parameter value to the kernel side. Then kernel create, then return the value. At that time, the memory area will be used for such a communication. If you make something like the two user process work with one kernel process, you can make such a thing. So this is the kind of the lightweight. So there's a lightweight processor. It's called the lightweight processor. Instead of considering all of that, we are going to consider such a partner or the related kernel and the user mode for the communication. That will be used for the thread later. So during the thread, I will explain a little bit more detail about the AWP. And another popular communication method that you know is socket. What does it mean, socket? So like this one, right? So if you already took the network class, you did programming. Anyone? Not yet? So 471 or 571, 572. So TCP programming. And all right, the UDP programming. So you can use such a client and server architecture for the communication. To do that, you need to establish the connection using what? OSI 7 layer. You want to quiz? List of the OSI 7 layer. Do you remember? Or you don't take the network class yet? No, please take. Among the OSI 7 layer, I do not remember. I graduated 20, 30 years ago. But there is a application layer behind whatever. Then, so we have the TCP, okay, transparent protocol, like that. TCP, the layer. We can use a TCP protocol for the communication. What is the characteristic of the TCP? You need to know IP address, port number. IP address and port number, then establish the connection. Then using the shape. And then send the packet data using that. Okay, depending on whether you preserve the connection or not. It's a connectionless or connection oriented, which means TCP or UDP. UDP is
user data
connection oriented. Always make the dedicate one, and it's a synchronous. On the other hand, the TCP is connectionless. Whenever you send the packet, you send. Because of the TCP, sometimes lose your packet. Okay. So if you have something very narrow bandwidth, but I want to watch the movie, like the Netflix or the others, you'd better have UDP. But UDP preserve such a bandwidth. So that is the socket program. Number of line is very short, so you can do the programming. Like this one is an example of the socket programming. So why don't you practice if you didn't do in the network class? So we can use such a socket approach model for process communication. Nowadays, this is a very simple, and we have enough the bandwidth and resource. But the problem of this one, whenever you make the socket, anyway we need memory. Okay, so it consumes the more amount the memory space. But nowadays it's not a big deal, so we use a lot the socket. And depending on the Java, the author of this text will actually regard the Java as another type of operating system. So in terms of Java provides also such a communication method within virtual machine, Java virtual machine. That is a remote procedure called the IPC. Okay, so but I'm going to skip that part. And the pipe is based on the message passing that I explained. Okay, so you can create the pipe. What is the pipe? It's a data structure also provided by your operating system library. Using the system library, you can create a pipe. Then, using that pipe, you can communicate. Like one of the examples is the pipe of this. There are different types of the pipe, like the anonymous pipe is for public, anybody can use. Or you can specify the name, the pipe. That name can be used for in case the process specify the name. Okay? That is the name of the pipe, that is the end of the process. Actually, sometimes I offer the warming up project to create the process and communicate using one of the methods. So one example of you are not sure whether my operating system use that. Why don't you open the code? Then we are going to start before that. Meanwhile, so let me this time use the VMware, my VMware. So for example, recommend to see all the interprocess communication research. Like you can see the IPCS minus A is A means always all the information. So this is a shared memory. So key of the each allocated memory. Each of them are used for communication between or among the processes right now in this operating system. Okay. Then there is a message queue. There's no message queue is created, but if you create, it will be appeared here. Then there's another one for the communication semaphore. We will discuss what is the semaphore. Semaphore is used for not only communication but mostly used for something locking. Okay, semaphore is a very simple data structure. Sometimes it's 0 or 1, but it can be used for the communication for what? It's locking to address the problem of the synchronization. So this is one of the good commands. So even you can, if there is something problem on the ship, for example, what is the Oracle? Oracle is the database management system in the database. When you start your Oracle database instance, what happened? Oracle actually, most of the time when you start any kind of program, it will start the processes. Not only one, sometimes many processes. Plus, Oracle reserved the memory area using this one, shared memory. So it will be very large, like 2 GB memory will be created. That area will be used for only communication in Oracle application. So you can actually manage. In case of what? Like the open process, I'd like to kill the process. Even though you kill the process, sometimes this one will not be free. Then firstly, you can free the such a shared memory process also. Okay, so that's the end of chapter 3. Let's have the quick quiz.